Okay, so now we will go into creating your own types. And here in Kotlin you use classes. So a class is a custom data type that can have both in data and potentially methods as well as or functions embedded in the type. Okay, so let's create a class for person. Okay, and for a person we will say that it's usually defined with a name and an age. Okay, okay, great. So we can say p1 equal equal 15. So, okay, so we created a class here that has a person, and of course this is a mistake because it's p1. Let's run again. Okay, so person 1 is 15. Okay, so this defines a class with just data in it. Okay, so pretty easy. So let's say we want to make this interesting and have a function that operates on this data. So you can say fun birthday and birthday ages the person by 1 year. Okay, does this build? It's fine. So let's say here p1 dot birthday, and then let's try to print the person again and see what will happen. Nice. Okay, so let's do something here. What will happen if I try to print person? It will just tell you that this is a person of type. This is an object of type person at this memory location. So not very useful. Okay, so are there ways to improve that a little bit? Yes, we can convert this into a data class. So if you run, so here when you add this modifier data to your class, Kotlin by default will implement the necessary functions in it to allow it to first present itself as a readable string. Okay, it can also allow you to make a copy of it. So let's see, p2 equal p1. Okay, you see p1 and p2 have the same name with some h. Let's try something interesting. So here, look what happened here. So I created a new variable pointing to P1 and I called birthday and I printed both of them. Because I did equal like this, effectively P2 is just an alias, or like it's a variable pointing to the same object as P1. So when you did birthday on P1, it didn't really differ. How about if we want them to be different copies? Let's run, see what will happen. See what happened here? P2 give us age equals 16. This is very interesting. So here, having a data class, you can make a copy of it. Another thing as well, you can check if P1 and P2 are equal, and then you can check them here. It's true because I didn't modify anything, but then here I modified them. If we remove the data modifier from the class, things will go weird because you cannot copy it anymore, right? So one important thing as well is that now when you modify the class, you can add, these are like, they call properties. So this class has two properties, a name and an age. See that here I defined the name as a val, so it's constant, and age as variable, right? So I can say p1.age, update that by 10, and then but I cannot really change I cannot do it because it cannot be reassigned. Only if I say var I can do that. And in this case, just to verify, the name has changed. Okay, so this is the main differentiator. So what else can we do? We can also have calculated values here. So you can say you see, we added this address thing. Running p1.address, I can access it by name. Okay, can I modify it? Yes, I can. Okay, so what's the difference between address and name? The main difference is that name can be initialized during creation by a value from the outside. So you as a user can modify, can in the creation statement can set the name. but the address has an initialized value, and you can access it and modify it later. Just for fun, p2 is not touched at all. Okay, so this is kind of an overview of classes. So one other concept that's very important is nullability. What does this mean? So here, like, I created person and set it a value. So this variable always have a personal value. Sometimes you don't want to do that. Sometimes you want to create a variable of a certain type that may not have a value, and then you set it to a null, which is, think of it as an alias for not having a value. So what you do here is p3 is person equal and then so I initialized p3 as person that's null. If I try to print it, it will tell me null. Once I assign to it an actual person value, it takes this value. All right. So what happened if I accessed anything from this thing? So say here the compiler doesn't like it because this is still a null. So I can do this. See, it tell me null. So when I access it, when I look at the null value of it, it will tell me the name of the null value, which is null, right? But once I assign it, it's very interesting is that I can access the name and I don't need the question mark anymore. So how can I use the null? So p3 okay, let's put this in a function just to properly demonstrate it. So we're saying doesn't have a value. Okay, so now let's see. Let's null check p3 here and null check p3 after. See what will happen. Sorry, I used. So our null checker function, the first time it received a null person, so it said it doesn't have a value, and then the next time, next call, p3 was already initialized, so it says that it has a value. The other thing as well that's pretty interesting on nulls is that you can do this. Then they go, oh, birthday like that. Nothing really happened, right? You can call a function on a null value. But if I did this, I can't. The best thing to do, if you look again in this function here, I can do that. V, I can call the birthday on it, but I cannot really call it here because the compiler really doesn't know, is this V really, was it an initialized person or null person? It doesn't know, so it cannot really let you do that. Here you can do, sorry, let's fix this. So p3, the birthday, you can call it here without a question mark because the compiler knows now that you already initialized it. If you did this, the compiler will not like it because it can easily see it from the previous statements, what happened to it. Okay, but in a function like this null checker, it always receives a nullable variable of person type. It cannot really know whether it was initialized or not. It doesn't have this context, so at compile time it will always prevent you from running without a question mark. Okay, I hope that was useful. Thank you.